show you how to solve this type of problem. Look at the diagram. This is a resistor. These are resistors. This is a wire. This is a wire. This is the battery. This is the symbol of battery. This you see here is the symbol of resistor. This is the resistor. This is a resistor. Now, this resistor and this resistor are connected in series. Why? Because the same current will pass through them. So when resistors are connected in such a way that the same quantity of current passes through them, then they are connected in series. Now look at these two resistors. Follow this current. Once it reaches this junction, it will divide. A part of the current will flow through this resistor, another part will flow through this resistor. So different. Now to solve this problem, you must determine the effective resistance. One resistor that can do the work of all these resistors, you must be able to determine that particular resistor. So once you determine it, you now use Ohm's law and you are good to go. Calculate the current flowing through the circuit. For us to do that, we need to determine the effective resistance. So let me start like this. When resistors are connected in series, the effective resistance is the sum of the resistors, or the sum of the resistance. So this and this are connected in series. So I can reduce this resistor, this and this. So one single resistor and then one single resistor. This is what I want. This is 6 volts. This is the current passing through the circuit. This is what I want to achieve. This is the resistor, the effective resistor in parallel. This is the effective resistor in series. Now to get my RS, I'll simply add this and this. 3 plus 1. That will give me 4 ohms. So this is 4 ohms. To get these resistors, when resistors are connected in parallel, we use this formula. RP will be equals to R1 times R2 all over R2 plus R1. If there are more, you continue. R1 times R2 times R3 times R4 and so on. Then you still add them. Here, our R1 is 5 times 10 all over 10 plus 5. That will give us 50 over 15. 5 can cancel this to give us 3. 5 here is 10. So I have 10 over 3 ohm. So this equals to 10 over 3 ohm. So the circuit has reduced in complexity from this to this. Now we need to get another one resistor that will serve the work of these two resistors. So let that resistor be R. Then we now have a circuit of this form. That's what we want to achieve. At the end of the day, I'll have this is the battery. This is my 6 volt battery, and that's the effective resistance. So to calculate this effective resistance, remember what we said. This resistor and this resistor are now connected in what? In series, because the same current will pass through them and return back. So just add this and this. So my R will now be equals to 4 ohm plus 10 over 3. That will give us the LCM is 3. That will give us, this time this is 12 plus 3 divided by 3 is 1 times this 10. That gives us 22 over 3. So this is 22 over 3 ohms. Now we apply Ohm's law. V equals to IR, or I equals to V over R. Let's remember Ohm's law using this triangle. We can always use this triangle to remember Ohm's law. V equals to IR, or I equals to V over R, or R equals to V over I. With this, you always remember Ohm's law. So we now have V I equals to V over R as what we want. So we now have the I equals to our V. Our V is 6 divided by the total resistance. The total resistance is now 22 over 3. This is the same thing as 6 times 3 all over 22. 2 here is 11. 2 here is 3. 3 times 3 will give us 9. 9 over what? 11 amps. That's the answer. 9 of 11 amps. So check it. That is number B. So B is the correct answer.